Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Computer Vision. Part 2. Advanced Sight, Understanding Action and Generating Images. Remember how in Part 1, we taught computers to see objects like a dog or a car? That was like teaching a toddler to name things. Today, we're going much further. We're teaching computers to understand what's happening in a video, like a dog running or a car turning. And even cooler, we're going to explore how AI can actually create brand new images. Like imagining a dog that's never existed before. Get ready to give your AI advanced sight and imagination. Imagine watching a movie. It's not just one picture, right? It's a rapid sequence of many pictures, called frames. For computers, a video is exactly that. A super fast flipbook of individual images. To understand movement, our AI doesn't just look at one picture. It compares multiple pictures, frame by frame, looking for changes. Developers' eye view. Asterisk as developers, when we work with video, we often treat it as a stream of individual image data. We process each frame, then use algorithms to spot differences or continuities across frames to detect motion. Think of it as writing code that says, is this pixel group moving from here to there in the next millisecond? Single quote. Once a computer can see movement, it can do two amazing things. 1. Object tracking. Asterisk imagine a detective following a suspect through a crowded street. Object tracking is just like that. The AI locks on to a specific object, like a car or a person, and follows its path across all the video frames. 2. Activity recognition. This is about understanding what the tracked object is doing. Is the person running, jumping, or waving? Is the car accelerating or braking? It's not just I see a person. It's I see a person waving. Developers' eye view. Asterisk we build models that identify an object in one frame, then predict where it will be in the next, refining its position. For activity, we train the AI on sequences of movements associated with specific actions, so it can recognize patterns, like a series of arm movements signifying a wave. So far, we've talked about AI understanding what it sees. Now, let's talk about AI creating what it imagines. This is the magic of generative AI. Instead of just identifying a cat in a picture, a generative AI can actually draw a brand new cat that has never existed before. Perhaps even in a style you describe. It's like teaching your computer to be an artist. Developer's eye view. Asterisk from a coding perspective. Instead of building a model that gives you an output like cat, a classification, or coordinates, an object detection, you're building a model where the output is the data itself, a new image, a new piece of text, or a new sound. It's about generating synthetic, but realistic, content. One popular way AI creates images is with something called GANs, or generative adversarial networks. Imagine a clever counterfeiter, the generator, AI, trying to print fake money, and a super sharp detective, the discriminator, AI, trying to spot the fakes. The generator tries to create images that look real. The discriminator looks at both real images and the generator's fakes, trying to tell them apart. Asterisk they train each other. The generator gets better at faking, and the discriminator gets better at detecting, until the generator can create fakes so good even the discriminator can't tell the difference. Developer's eye view. Asterisk you're essentially training two neural networks simultaneously, making them compete. The loss function, how we measure error, for the generator is based on how well it fools the discriminator, while the discriminator's loss is based on how accurately it classifies real versus fake. It's a game-theoretic approach to learning. Another incredible way AI generates images. which you might have seen with tools like DALL-E or Midjourney, is called diffusion models. Imagine starting with a blurry, static-filled image, like an old TV with no signal. A diffusion model learns how to slowly, step by step, remove that noise, revealing a clear, beautiful image that matches your description. It's like having a magical eraser that can turn static into art. Developer's eye view. Asterisk these models are trained to reverse a process of gradually adding noise to images. When generating, they start with random noise and iteratively denoise it, often guided by a text prompt, like a futuristic city at sunset, until a coherent image emerges. It's a complex process of probabilistic modeling, but the output feels incredibly intuitive. These advanced computer vision techniques aren't just cool party tricks. They're solving real problems and opening new doors. Understanding action. Asterisk powering autonomous cars to understand traffic flow. Enhancing security with intelligent surveillance. Analyzing sports performance. And enabling gesture-controlled interfaces. Generating images. Asterisk revolutionizing art and design. Creating realistic virtual environments. Generating synthetic data for training other eyes, when real data is scarce. And personalizing content creation. Developer's eye view. Asterisk as developers. Understanding these models means you can build applications that interpret complex visual scenes, create unique content on demand, and push the boundaries of human-computer interaction. The demand for these skills is exploding. We've gone from teaching AI to identify objects to helping it understand dynamic actions and even creating its own art. This is just the beginning. The world of computer vision is constantly evolving. I encourage you to explore open source projects, try out some AI art generators, and even dabble with simple code examples using libraries like TensorFlow or PyTorch to see these concepts in action. Your imagination, combined with these powerful AI tools, is the only limit. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.